All right, the final video that we're going to look at in terms of the laws of supply and demand and how markets operate is going to be all about combining supply and demand. And when we combine supply and demand, we create what's known as equilibrium. And that's the point where the supply and the demand curve intersect. So we have our downward sloping demand and our upward sloping supply. Equilibrium is really the situation where the quantity supplied and the quantity demanded are equal. So equilibrium kind of means balance, and it's the point where quantity supplied and quantity demanded come into balance. This is also known, the equilibrium price is also known as the market clearing price. And to find equilibrium price, what we're really going to do is we're going to find the point where the supply and demand curve intersect one another. So on this graph, that's going to be this point right here. We have our upward sloping supply curve. We have our downward sloping demand curve. That's going to create for us an equilibrium price of $2 and an equilibrium quantity of 7 units. So at $2, 7 units are supplied, 7 units are demanded. Now, disequilibrium occurs when quantity supplied and quantity demanded are not in balance with one another. There's two possible types of disequilibrium. There's a surplus, which is when quantity supplied exceeds quantity demanded, or a shortage, when quantity demanded exceeds quantity supplied. So surpluses occur when the price is too high. So in this market, the price of an ice cream cone is $2.50. At $2.50, 4 units are demanded, but 10 units are supplied. Because the price is higher, more sellers want to get in on the market and make money. Except consumers, because of this high price, can't afford to buy that many ice cream cones. So the net result is there's going to be 6 ice cream cones that end up going unsold. Now, in a free market, in a market free from government intervention, in a market free from market failures, which we're going to learn about a little bit later, we would expect when there's a surplus that price is going to come down to the market clearing price of $2. Now, a shortage is going to occur when the market price is too high. So in this market, the market price is $1.50. Okay, the market clearing price though is $2. Because the price is so low, consumers see this as a good buy. They see it as a good opportunity. They're going to want to buy 10 units, but producers can only afford to produce 4 units. As a result, consumers want to buy more products than products are available. The price is, generally speaking, going to want to rise. Okay? I always like to use tickets as an example of this. When there's a really popular ticket, let's say if the Cubs go to the World Series, more people are going to want to go than tickets are available. And what we would expect to have happen is the price is going to rise. And you see this in the form of scalping or sites like StubHub, that people are charging a much higher or a premium on the tickets that they have. The next thing we need to look at is what happens when the market conditions change. So what happens when we have changes to the underlying market condition, those factors that we talked about before, IP10 and I10, the 5 factors that could shift demand, income, price of related goods, tastes and preferences, expectation, number of buyers, and the 5 factors that could shift supply, input costs, technology, expectation, number of sellers, and nature and government. So when analyzing how a change in market conditions affects a market, I really have pardon me, 3 steps I want you to follow. Step 1, ask yourself, is this a shift of supply or a shift of demand? So that's the first thing you have to ask yourself. Is this IP10 or is this I10? Step 2, once you've determined if it's the supply or demand curve that's moving, determine what direction the curve is actually shifting. Step 3, use the supply and demand diagram to see how the shift changes equilibrium price and equilibrium quantity. Okay? And the basic rule is, when in doubt, graph it out. Don't skip these steps. Okay? Take your time with these problems. Pay attention to details. So here's a hypothetical example. How will hot weather affect the market for ice cream? Okay, so you're going to ask yourself, is it a shift of supply or demand? Does it shift to the right or the left? What happens to price and quantity? Graph it. Okay, so here we have the market. Hot weather's effect on the market for ice cream. Well, this is going to be a change in consumer tastes and preferences. Because it's hot, more customers are likely to want to buy ice cream. This is going to cause the demand curve to shift to the right. The result is going to be the price is going to rise, okay, and the quantity is going to rise as well. So we're going to have a change in this market of demand. The entire demand curve is shifting to the right. However, at the same time, this change of demand causes a change in quantity supplied. Now, we're going to do a couple of more practice problems on this, and I'm going to show you kind of how you do this when more than one curve is shifting. All right, so now I'm going to demonstrate how to solve some of these problems. So the first problem that I'm going to demonstrate is simply shifting a single curve, okay? So first thing you have to identify is what's the market you're looking at, okay? So this is a sample problem you might get. Graph and explain what will happen to the market for Cubs tickets when they win the World Series this year. So the market is Cubs tickets. Next thing you have to identify is which curve is shifting. So when the Cubs win the World Series, is this going to be a shift of supply or a shift of demand? Well, this is going to be a shift of demand, and the primary cause of the shift of demand is going to be a change in consumer tastes and preferences, okay? So what's going to happen, I can identify as my demand curve is going to shift to the right from D to D1. And again, I draw an arrow showing which way it moves. The point where the new demand curve intersects my old demand curve becomes my new equilibrium price. I'm going to go ahead and label that P2. And my new equilibrium quantity, which I'm going to label Q2. Now, so far so good. I've pretty much solved the problem. The final thing I have to do is I have to show my results. So in this market, price is going to rise, quantity is going to rise. Okay? So it's very important that we actually demonstrate our results, which here is going to be price rises, quantity rises. Okay? Now, let's look at what happens when we have two curves that are shifting. So again, first thing you want to do is you want to identify the market. So here the market is going to be water. I helped you identify the market. And the problem is, graph and explain what will happen in the market for water when there is a severe drought and more farms require intensive irrigation are created. Okay? So first, there is a severe drought. Second, we have more farms that require intensive irrigation. Okay? So when you solve these problems, these multiple shift problems, it's very important that you draw more than one, graph. Okay, and I've already set this up with two graphs. Okay? Don't try and solve a multiple shift problem on just one graph. It gets to be too confusing. When you solve these problems, put them on more than one graph. So here's my first shift. I'm going to do this on graph 1. There's a severe drought. Well, if there's a severe drought, that's going to be a shift of supply, and it's going to be a shift of supply to the left. We're going to go from S to S1. And the cause here would be nature. Okay? The point where S1 intersects my original demand curve is going to become my new equilibrium price, which I'm going to label P2, and my new equilibrium quantity, which I'm going to label Q2. Now, off to the right, I'm going to put my results. Price goes up, quantity goes down. Okay? That's shift number 1. Now we have to see what's going to happen in shift 2. Okay? More farms require intensive irrigation are created. Now, shift 2, more farms, is going to be a shift of demand. This is going to be a change in the number of consumers. My demand curve here is going to shift to the right from D1 to D2. Okay, there's my arrow. The point where it intersects is my new equilibrium price, which I go ahead and label P2, and my new equilibrium quantity, which I go ahead and label Q2. And now for shift number 2, I'm going to go ahead and do the same thing. Price goes up, quantity goes up. Now, here's the important part, okay? To find my final result, I have to look what happens shift 1 and shift 2. So shift 1, price goes up, shift 2, price goes up. I can say definitively, price goes up. In in graph 1, quantity goes down. In graph 2, quantity goes up. So quantity is moving in opposite directions. Anytime quantity moves or price moves in more than one direction, the whole quantity or whole price becomes ambiguous. So the answer is going to be price goes up, the effect on quantity is ambiguous, and I represent that with a question mark. Okay, so this would be 2 shifts. Now you could just as easily do 2 shifts as you can 3. So here we have a new market. Now when I do 3 or more shifts, it's again important I use 3 or more graphs. Okay, so however many shifts there are, that's how many graphs I want to use. So here the market is automobiles, and the problem is graph and explain what will happen in the market for automobiles when the price of steel rises, the price of gas increases, a new and more convenient and cost-effective public transportation is created. Okay, so I have 3 shifts. The price of steel rises, the price of gas increases, a new, more convenient and cost-effective public transportation system is created. Okay, and whenever I do these, it's best to take them, one at a time. So shift 1 is going to be the price of steel rises. Well, steel is an input into the production of automobiles. If input costs rise, supply shifts to the right. So I'm going to go from S1 to S2. The point where they intersect is my new equilibrium price, which I'm going to go ahead and label as P2, and my new equilibrium quantity, which I'm going to go ahead and label as Q2. So here, price rises, quantity falls. All right, shift 2, price of gas increases. Now, it's important to think about the relationship between gas and cars. Cars and gas are complementary goods. Those are 2 goods that are bought and used together. If gas is more expensive, I would expect fewer people to want to buy cars. That's going to cause a decrease in the demand for cars. So my demand curve is going to shift to the left. We're going to go from D to D2. The point where my new demand curve D2 intersects is going to become my new equilibrium price and quantity, which I'll label P2, Q2. In graph 2, price goes down, quantity goes down. Now, in graph 3, the scenario is a new, more convenient and cost-effective public transportation system is created. Okay, I'm going to graph this down here in graph 3. Now, public transportation and cars would be substitute goods, goods that are used in place of one another. If public transportation is suddenly much less expensive, I would anticipate the demand for cars is going to fall. Okay, demand is going to shift to the left. I'm going to shift my curve from D1 to D2. The point where it intersects is going to become my new equilibrium price and quantity, which I'm going to label P2, Q2. I'm going to come back here to my solutions. On graph 3, price falls, quantity falls. Okay? Now, let's take a look at my answers. In graph 1, price rises. In graph 2, price falls. In graph 3, price falls. Anytime I have price moving in opposite directions in 2 graphs, the whole thing automatically becomes ambiguous. I don't know. Quantity falls, quantity falls, quantity falls. So in all 3 graphs, quantity falls. My correct answer is going to be price is ambiguous. I can say for certain quantity is going to decrease. Okay? So it doesn't matter how many shifts in a row. If you have one that shifts in the opposite direction, the entire statement becomes ambiguous. And the reason for this is because we don't know the magnitude of the shifts. Shift 1 could be much, much bigger than shift 2. We have no idea. So because we don't know, we say the entire statement is ambiguous. All right, last one, we're going to look at 4 shifts. Okay? In this market, the market is PC computers. And the problem is, graph and explain what will happen in the market for PC computers when the price of Macs fall, the price of computer chips rises, more students begin to attend college, and the United States embargoes trade with China, which is a large supplier of computers. Okay? So again, we have 4 shifts. Price of Macs falls, price of computer chip rises, more students attend college, United States embargoes trade. Okay, so we have 4 different shifts. We have to draw 4 different graphs. In graph 1, we're just going to be looking at what happens when the price of Macs falls. Well, Macs and PCs are substitutes. If Macs are cheaper, people will buy more Macs and fewer PCs. The demand curve is going to shift to the left. Okay, that's going to create my new equilibrium price, P2, Q2. I'm going to put my answers over here. Price goes down, quantity goes down. Price of computer chips rise. Computer chips are going to be an input cost. If inputs are more expensive, supply is going to shift to the left. Go to graph my curve moving. Okay, this is going to be my new price and quantity, P2, Q2. In graph 2, price rises, quantity falls. Okay, let's go ahead and look at graph 3. Graph 3, more students attend college. If more students attend college, I would expect the demand for PCs to rise. Okay, college and PCs, I would argue, are probably complementary goods. When kids go to college, they want to get a new computer, so my demand curve is going to shift to the left. This is going to become my new equilibrium price, which I label P2, my new equilibrium quantity, which I label Q2. Okay, I'm going to go back up here. Price rises, quantity, rises. Let's go and undo that. So price rises, quantity rises. All right, let's look at graph 4. Graph 4, the United States embargoes trade with China. China is going to be a supplier of PCs and PC parts. If the United States embargoes trade, I would anticipate the supply of computers to decrease. Supply is going to shift to the left. Okay? The point where the new curve intersects my old demand curve is going to be my new equilibrium. I'm going to go and label that P2Q2. I'm going to come back here to my answers. I'm going to put my answer. Price rises, quantity falls. Okay? Now, I'm going to go ahead and look back over all of my answers and see what happens. So in graph 1, price falls, price rises in graph 2, price rises in graph 3, price rises in graph 4. Because price falls here, the whole statement is ambiguous. Okay, I'm going to put a question mark. In graph 1, price falls, quantity falls, quantity rises, quantity falls. Because they move in opposite directions here, the whole statement is ambiguous. My answer is going to be the question mark. So here, the effect on price is ambiguous and the effect on quantity is ambiguous. And that can be your answer sometimes. Now, kind of the keys to success here in terms of answering these problems, multiple shift problems. Number 1, follow the steps. Okay, the 3 steps I talked about. Number 2, pay attention to details. And probably the 3rd and most important step is to graph it. I can't underestimate how important that is. Each curve should have its own separate graph. Some students are going to try to skip steps. Some students are going to try to put all the shifts on one graph. It's not worth it. Take the time to draw an extra graph. You could just take a second, okay? Draw a supply and demand curve. It only takes 1 second. Then demonstrate what the shift is. It's worth the extra time when you're solving these problems. We're going to do a lot of practice problems on these in class, so if you have any questions, please bring them.